Welcome to Unit 5, Part 1. Talking about relationships in triangles. The first part talks about bisectors of triangles. And remember, the word bisector means to divide in half. So a perpendicular bisector is a line or ray or segment that is perpendicular to a segment at its midpoint, meaning it's not only divides the segment in half, but it also forms right angles at the segment. Therefore, it is called a perpendicular bisector because it's both perpendicular and the midpoint. So the perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment, right? Because if this is the midpoint, then these two parts are equal, which means it's equidistant from the endpoints of A and B. And likewise, if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. So notice if it's equidistant, if AE and BE are the same, meaning it's equidistant from E, then that is the perpendicular bisector. So for example, here it says to find PQ. Well, notice this is the perpendicular bisector because not only is there a right angle, but also PS and SR are the same. So that means that these two segments, PQ and RQ, must be the same. So therefore, 3x plus 1 is equal to 5x minus 3. And then that gives you 2x, and then you add 3, so 4, so x equals 2, and it wants you to find PQ, so PQ would be equal to 3 times 2 plus 1, which is 7. So same thing here with BC. So since this is the perpendicular bisector, that means AC and BC would be the same. So since AC is 8.5, BC is also 8.5. For EH, well, same situation. Since we have the perpendicular bisector here, that means 5x minus 20 is equal to 3x minus 4. So we solve for x. So we get 2x equals 16, x equals 8. And then to find EH, we put the 8 back in. So 5 times 8 minus 20. So 40 minus 20 gives us 20. All right, so for XY here, since these two segments are equal and it's perpendicular, that means this is the perpendicular bisector, which would make these two equal. So that means XY is equal to 6. All right, if you draw all the perpendicular bisectors of a triangle, they will meet in the center in what's called the circumcenter of the triangle. That is basically the center of a circle that is circumscribed, meaning it's around the triangle. So that's why it's called the circumcenter. And the vertices, from the circumcenter, the vertices are equidistant, meaning like here that BP would be equal to PA, which would be equal to PC. Those three things are equal. So from the circumcenter, the circumcenter would be equidistant from the vertices of the triangle. So here we'll make a rough sketch of a circumcenter. So we first have to draw a circle that is circumscribed, meaning it's going to touch all three vertices. Okay, so there, came close. So it touches all three vertices. And then the center of the circle would be here. So we'll call that P, which means then you have perpendicular bisectors that go through it. So notice here would be a perpendicular bisector. There would be perpendicular bisector. And then we would also have one that went, sorry, it has to go through the center. So we'd also have one that went through like this. So it'd be perpendicular here and bisect there. Now what that means is that if this is the circumcenter, it means that from here to there, from here to there, and here to the vertice there, these are all going to be congruent. And that's what it means to be the circumcenter. It's that it's the center of a circumscribed circle, and it's also equidistant from the three vertices of the triangle. All right, but the circumcenter is the intersection of the perpendicular bisectors in a triangle. All right, so the next kind of bisector we have is what's called an angle bisector, which divides an angle into two equal parts. But also an angle bisector, if a point is on an angle bisector, it is going to be equidistant from the sides of the angle. So notice FD here and FE would be the same. And if they're equidistant, they're also perpendicular, because a perpendicular segment is how you measure distance. So if you look at this picture here and it says to find DB, and it tells you here that this is an angle bisector, if CD is 5, that means DB is also 5. So here for QS, since this is an angle bisector, then these two have to be equal, which means we have to set 4x minus 1 equal to 3x plus 2, subtract 3x, and then add 1. So we get x equals 3. And then to find QS, we put the 3 in. So 4 times 3 minus 1 is 11. All right, so for the next one, it gives you the angle, and it gives you that this point W is equidistant from the two sides. So therefore, this must be the angle bisector, which means if this is 28, then this is 28, which means XYZ, the whole angle XYZ is equal to 56 degrees. So go ahead and look at the next one and see if you can come up with the answer. All right. So it's equidistant from H. So that means this is 30 and this is 30. So HFI is 30 degrees because HFI is only half of the whole angle. All right, the Incenter theorem. So angle bisectors, the intersection of the three angle bisectors of a triangle is what's called the incenter. It's the center of an inscribed circle, a circle that would be inscribed in the triangle. And once again, the incenter will be equidistant from the midpoints of the sides. So it's going to be equidistant from the sides of the triangle. So this PD, PF, and PE, those would all be the same. So for example here, it says S is the incenter of triangle MNP. So find ST. Well, we know that ST, SU, and SR should all be the same. So to find SU, we have to use the Pythagorean theorem, which says that, the square of the legs in a right triangle the sum of the squares of the legs in a right triangle is equal to the hypotenuse squared. So you would go x squared plus 8 squared equals 10 squared. Subtract the 64, 36. So when you take the square root, you get x equals 6. So SU is 6, which means all these little parts are 6. And then it says find the measure of angle SPU. SPU. Well, remember this is an angle bisector, so these two are equal. But if you look in this triangle here, in RNP, you have 90, 28. All right, so 90, 28, so 180 minus 90 plus 28 equals 180 minus 118, which is 62. And since SPU is half of 162, is half of 62, so angle SPU is equal to 31. All right, so look at number 11. Same situation. It says find GF. Well, GF is right here. And so we have a right triangle, so we could go 5 squared plus x squared equals 13 squared, because 13 is the hypotenuse of the right triangle. So 25 plus x squared equals 169. Subtract 25 from both sides. X squared equals 144. Take the square root, and you get x equals 12. So GF is equal to 12. So then it says find the measure of angle BCD. So we want to find the measure of angle BCD. And this is a right angle here. And we also know that this is an angle bisector. So this is 35. So we have 90 and 70. So 160, which means there's 20 left over for angle BCD. So it's 20 degrees. All right, so let's look at number 12. All right, so number 12, A is the circumcenter of triangle triangle LMN. So that means it is these are perpendicular bisectors here, which means there's right angles and it bisects. And it also means these are equidistant. So LO is equal to 8y plus 9. And ON is equal to 12y minus 11. So we have to set them equal to each other. So y is equal to 5. So in part B, it says find x. So let's move those. So find x if angle of APM, M is 7x plus 13. Well, APM is also a right angle, so we can set 7x plus 13 equal to 90. So it's equal to 77. So x is equal to 11. And then for C, it says find R if AN. So AN is going to be right here. is 4r minus 8, and AM is 3 times 2r minus 11. Remember, it's equidistant from the vertices, so that means these two are congruent. So 4r minus 8 is equal to 3 times 2r minus 11. So 4r minus 8 is equal to 6r minus 33. So subtract the 4r and add the 33. So you get 2r equals 25, so r equals 12.5 for r. All right, so number 13. In the figure, point D is the incenter of triangle ABC. What segment is congruent to DG? Well, what segment is congruent to DG? It would be either DE or DF would be congruent to DG. What angle would be congruent to DCF? DCF, and that would be DCG, because it's the angle bisector. All right, so that concludes part 1 of our video notes. We will talk about part 2 next.